Hello, and welcome to the next episode of Cumulus on Cloud. I'm Robert Starmer, and I'm joined by our fabulous co-host, Lew Tucker.
Hey, guys.
Hey, Lew. So today we're going to discuss, now wait for it, and I know it's going to be surprising, but we're going to discuss cloud computing. So we're going to focus today on the idea of service mesh and why this tool and this connectivity model is so important and such a game changer in enabling and accelerating cloud adoption. So the question is, why should I look at service mesh as my principal secure connectivity partner in a way, right?
Exactly.
Yeah.
Well, in my view, it represents sort of this evolution of these large scale services that we've been on, from sort of monolithic apps, whereby, you have a large team, you've got an application that get hundreds of thousands to millions of lines of code. That makes it almost impossible to maintain it going forward. We think about Mythical Man Month in years past,
Yeah.
that it's just too hard. And so one of the ways to deal with that complexity is to break everything up into a larger number of smaller services, these
Right.
microservices, and the microservices, just one service is just around like managing passwords. Another is managing maybe a catalog. All of those things now become easier to maintain, but you're left with the question, how then do you hook them up and become back to present to the user a unified, integrated experience?
Right. And I mean, if you're taking a monolith app, and most companies that have built applications, that's what they've built, right? They started out with, okay, I need a tool, it needs to have users involved, it needs to have some kind of data storage, it needs to have like a number of all of these services. They often get built as one big app, right? And to your point, as you're trying to grow that and scale that, you start building separate applications, right? So you'll start to say, well, let's just manage our users separately. Or as we've started to see, and even what we talked about in one of the previous podcasts, security is changing because we want to look at identity and authorization and authentication as an entity unto itself. A lot of people are using third-party identity management platforms even to handle that one piece of the puzzle. So I've already started to break out of my monolith some of those core components, even if I'm not building them myself, right?
Exactly.
And so then the question comes, okay, how do I connect those things together?
Right. And then you're talking again about networking. So now
Right.
every component, and so maybe you have a team that's really focused on, let's say, managing a catalog, and they are a truly expert in that, managing the catalog, and that's running as a Kubernetes cluster, and they can use that to scale that up and down. But now they have to also be experts in security and in communications and what to do in the case of timeouts. And
Right.
so there's a lot of complexity that you don't want to have injected into each of those applications. Instead, you can offload that into what we're calling the service mesh.
Yeah, and especially when we were living in the world of the monolithic app, everything was under one control domain, right? It was one development team, and yes, it was getting bigger and bigger and harder to manage. That's the reason that we started breaking these things up anyway. And even if it's not microservice, I always joke that the idea of microservice is great. This thousands of little application components all doing wonderful, magical, mystical things. But the reality is that they're sort of micro monoliths, but they're monoliths in their own domain, right? To your point, a catalog team that really knows how to manage a catalog and presents an API. And actually, the first place that I saw this idea of service mesh was when we started to break things up. We said, well, we need a consistent API. This was the Amazon golden bullet was thou shalt create APIs and thou shalt not cross the API boundary other than through the API, right? Once you start doing that, you do have an interesting environment that starts to be created, because often those APIs are HTTP style APIs, whether it's RESTful or query based or what have you. But those APIs give us a really nice interface. And actually, again, the first place I really saw this was people were looking at API gateways as a way of saying, well, I'm going to put a single interface in front of all of my application components. And with that, I get wonderful value, right? Because I get suddenly an authentication point. Right? I can authenticate everything in one spot.
Exactly right. Yeah. And that's why I think that where the pieces sort of came from, I think that it was Google around 2016 decided to open source this project Istio, which really had those different components. And one of those key components for doing exactly what you're talking about was having a proxy server called Envoy There have been many others. There's been Linkerd, there's been Console,
Yeah.
there's been Nginx, widely used for a lot of different purposes. But
Right.
it is basically front end each of these microservices with another service, which is this Envoy proxy service. And that proxy service will talk to the other proxy services and manage all of the traffic and security and authentication. So the pieces started to come together around that time. And then we've seen it, deployed at Lyft and Twitter and Pinterest and other places who are really building very, very large applications out of a set of microservices.
Yeah. Well, I think the other part that was driving this interest in service mesh, I think it was Airbnb or Lyft, one of those two were one of the first to really publish this outside of their own internal use. There were lots of companies doing this internally. Like you said, the Linkerd guys came out of one of those environments.
Buoyant, I think. Yeah.
Buoyant, yeah. And they were all looking at how can we make this connectivity between these microservices easier, right? They'd already seen the API interface, a consistent interface, and then they were starting to try to figure out how you could handle making that easier to develop, right? It's like, how do I address the fact that I'm basically asking the developers to now secure every one of their services, again, leveraging potentially a centralized identity tool of some kind, right? So now I have to figure out how to integrate with that tool to make sure that my identities get matched. I think the other big component of a lot of this was the idea of mutual TLS. Right, so we had TLS or SSL, as most of us, I think, still think of it. At least as older folks think of it as, the sort of secure HTTP connectivity was really nice because it gave us a way of saying, hey, the server is who it is, right? Who it says it is. But we were able to flip that with the mutual TLS model to also be able to say, I know who the client is. I know who's asking for this request. And given the sort of the server client side model of web communication altogether, and APIs, suddenly we had a nice identity touch point with this API gateway concept.
Yes.
Tying that into the proxy means that now I have an API gateway everywhere, right? And I think that's right. Another really powerful component of this is that distribution of control and distribution of connectivity.
Exactly. And that's where I think that it was then constructed architecturally then sort of in two pieces. One is this kind of control plane API, which is managing the whole set of microservices underneath it, instantiating the application service, so to speak. And that control plane controlled the configuration of each one of those proxies. The proxies were generally implemented as sidecars to a container, so that when Kubernetes would spin up a container, because either it's growing in size or shrinking or whatever, when you spin up that thing as a sidecar, all traffic from that container now goes through that proxy.
Right.
And that is then controlled by that control plane. And the proxy, the control plane API, is the thing that tells each of the proxy servers what are the policies about who can talk to whom, how do you manage from an authentication service, the use of keys, rotation of keys, and it manages in the traffic flow as well for load balancing.
Right.
So it's a very integrated system with the rest of the Kubernetes ecosystem, and uses the lower level Kubernetes APIs and everything else to manage the individual containers as they come and they go.
I think that's actually kind of an interesting point, because I think a lot of us looked at service mesh as a tool in the Kubernetes space. That's really where I think it really exploded in terms of use. I have seen it outside of Kubernetes. In fact, the Google Beyond Corp, or Anthos, I guess is what they changed the name to, right? So the Anthos tool was a way of saying, hey, this idea of service mesh works really well. We've got this proxy. Now, I don't really care what's behind the proxy. I can do this in Kubernetes, right? I deploy a container, don't care what the application is. I don't have to deal with, I need a Java-based proxy style component, a library that I can plug into my app so that I can leverage all these wonderful capabilities. That central control piece is also really interesting. And that was, to me, that was the big value of something like an Anthos, was I can centralize that control maybe in the cloud context. So I can centralize the control in Google, but I can still tie this into my enterprise environment, right? We talk about this being not just a Kubernetes specific thing. Again, the benefits there were the ability to add this additional container, that little proxy, anytime I spin up or shut down and then remove that resource automatically. the Envoy proxy became the proxy of choice because it was API configurable without having to restart the service, right? So you could basically go and inject a new policy or remove a policy, and provide or remove access. So a lot of those components all came together, but suddenly we had this service that was, capable of handling the distributed nature of applications as we started to pull out pieces, right? Again, pull this identity out. The ability to reach outside of the company. I mean, being able to connect to an identity provider that's a third-party provider using that concept of mutual TLS says, yes, I am actually the client that wants to validate my credentials with you, not just some random guy hitting up your website over and over and over again trying to get in, right? Yeah. Having then that proxy in place, I really do think that proxy becomes the key, though, to the entire solution, right?
And that's why people have used many different kinds of proxies. So you can almost swap them in and out in the Istio architecture, whether it be Conduit, Console, Envoy, being able to use them for different capabilities. Because one of the other interesting points about this, so this is really networking technology built on top of Kubernetes, and it allows you to also then to really instrument the traffic and be able to observe the traffic that is happening. So you could set up alerts for if you see traffic that wasn't expected, or if you see repeated failures, for example, from one of the service, then Istio can respond to that. And you can have policy and you can have rules around that. So that if one service, for example, is continually failing or timing out, you can instruct the rest of Kubernetes to spin up more and load balance across that. So there's a lot of capabilities you can do as you now control the traffic and you observe what's going on in your environment.
Yeah, I mean, from a security perspective as well, now you suddenly can actually see the communication. You actually have traceable communication. When there are new protocols, right? There's the whole open tracing space. You get another topic that we're going to get deep into today. But that whole open tracing capability and the understanding of not just how does traffic get to an API to that, and in this case, it's actually the little proxy that's the first entry point into your application. But by doing that, I can now start keeping track of traces through the application space, so I can deal with sort of the security aspects of that at that level. But we also get additional benefits, right? So we get the sudden ability to actually observe the application platform across all of the different resources. And again, I don't want to keep losing this, because in my mind I do. I keep thinking about, oh, this application is running in some data center or in a cloud data center, in a Kubernetes cluster of its own. But I can suddenly easily span across clusters. I have that central authentication service, right? That to me is such a key piece of this. So central authentication, security. Now I add in observability. You had also mentioned the idea of load balancing, and yes, Kubernetes sort of does load balancing outside of the proxy, but the proxy can now start to inform that load balancing decision, right? It can be another endpoint for version changes, for example, right?
Right. Well, that's an important use case as well. So when you have your application running and you're on v20.1 and everybody's up to that rev or whatever, you can then say, okay, now I'm going to roll out a new 20.2 version. What you can do very easily with the Istio architecture is that traffic shaping. You can say, okay, bleed off 5% of the traffic over to, I'm going to deploy a new 20.2 version of a couple of my services, bleed some of the traffic off into it, take 5% or whatever, and see how it performs. And by monitoring that, you can say, yes, it seems to be standing up to that traffic, shift it over so now it's 10% or 15%, until finally all of the traffic is now over into your new version, and you turn off the old containers and they go away. Then you're entirely over onto the new system. This is canary kind of deployment.
Right.
Being able to introduce new versions rapidly.
Well, and I think the canary traffic management, this ability to sort of drive policy, and we all often think about this in its simplest terms, which is really wonderful, right? At the simplest, I can just say 1% of my traffic goes over here, but I can start doing things because all my traffic is being directed through yet another load balancing capable resource, right? That proxy interface. Because I'm directing it through that, I can suddenly start doing things like looking at cookies, and based on cookies, I can redirect traffic. So I've actually done this with simple applications where you're like, well, let's give John access to the cluster, or let's give Mary control of her environment so she can actually log in and validate that she gets the new version, and she can validate that it's actually doing the things that she wants. And that's the human interaction, but you can also do that programmatically, right? So suddenly you have policy-based control of what resource and even what version of an application you give somebody, right?
Exactly.
And you know, we think about this in terms of sort of releasing new versions, but what about customer-specific versions, right? I'm going to give a feature just to one customer. Now I have a way of capturing that information and driving it to just the version of my app that runs this. I think the other thing that really is interesting, and it's another key driver that makes this service mesh so powerful, is containerization, right? We talk about automation of all things. You know, here you talk about, let me just spin up a little additional resource. This only happens through automation. This only happens because we can turn on and turn off resource at that container slice, that process slice, so effectively.
Exactly. And that's why I think it's important to note that when we're talking about we're centralizing these policies and everything else, remember that's logically centralized. It's still going to be running over many clusters themselves or whatever. But the policies is what we want to have universally distributed across that, so that they're all acting in the same way. And Kubernetes gives that capability because we can tag containers with different properties. So we can have those tags themselves direct a lot of where the traffic is going. And we're unifying between whether it's a service or a user, they're following the same set of policies and the same architecture.
Yeah, the policy centralization, the authentication centralization, the ability to use third party, you know, to basically continue to microservicize these different resources, really cannot be overstated. The importance of that, right? You know, traffic management shaping. I think the other thing is that because of the proxy model. Again, the concept of service mesh has been around for quite a while. The proxy model, containerization, and Kubernetes really, I think, brought it into the forefront because people were able to build more small components. Right? I mean, the classic example of an application, I think, Lew, that you've been talking about before was thinking about, yes, I have a front end. So, of course, there's usually something that's doing some additional processing, additional application level routing. There's that front end, and that front end is driving things to, well, where's my login service? You know, where's my data lookup service? Where is the actual business processing logic service, right, that I'm going to send these different components to? And we're actually able to make that management happen. And internally now, because of the additional observability that I get, and because of the traffic management policy, I can actually test different back-end services. So we often think about the front end. Yes, I'm going to give you version 2 and you have version 1. Well, what if I change my catalog management API, and I want to make sure that management API still works? Can I do things like suddenly I have access to and control of the connection? I can inject faults. How does my application behave if I'm not responding appropriately? Right. Exactly. You know, where does my shopping cart go? Right. Classically, in sort of the e-commerce world, how do I deal with a lot of these things? So you know, that ability to really start breaking our applications up and more effectively making sure that they're not breaking our application as a whole. When I do that, I think it's another one of those benefits that we get out of enabling service mesh.
Exactly right. And that's why, I mean, it's exciting to me in terms of looking at the evolution. And that's why from these monolithic applications, and then we started having cloud computing. Now we had applications that had to span multiple clouds. And we are using things such as the service mesh and Istio architecture to bring those things back together again. So from the outside, it might look like a single service. It's a Google search service or whatever, but it's got hundreds and hundreds of microservices behind it that are now communicating with each other and being able to be managed, as we've been talking about many times, I think, in this, as, you know, configuration as code. This is the configuration and how these things implement the policies is all expressed in code so that you can manage it just like the rest of your application stack.
Yeah, I mean, infrastructure as code is certainly one key aspect to this. Policy as code is really what a service mesh is enabling as the expression of your policy. I do want to also sort of bring up again the whole idea of sort of developer burden, right? We're talking about how, if you're going to implement this service mesh, the really nice thing is you can now deal with polyglot applications, right? With that sidecar container, and sidecar is sort of a Kubernetes-y term, but in cloud in general, it's basically having yet another process running, right? So because people do also use service mesh on older school applications. You can tie your classic applications into your service mesh through a gateway type resource, right? And that's one of the, again, this idea that it doesn't have to be in one Kubernetes cluster. It doesn't have to be in one cloud, right? Being able to deal with multi-cloud, hybrid. Here's my old data center that I still need to incorporate. It's got all my data in it still, right?
Exactly.
How do I connect those things together? But really, we can reduce developer burden as they continue to expand the capabilities of their application, injecting faults and dealing with circuit breaker applications, making sure your application behaves properly when something breaks in the back end. Service mesh helps there. Helps with policy, helps with security. It's it's the Swiss Army knife, right?
Really and so I think the open source team behind Istio at this point, as part of the Kubernetes environment, is just really firing on all cylinders. And I urge people or viewers to look at istio.io, istio.io. That's where there's a lot of very well-written tutorials and documentation, which will bring people through and show them the architecture and the different components so that they can start to implement it in their own environments.
Yeah, I mean, I think Istio is the principal version of service mesh that people use today. I mean, Lew, you mentioned a couple of others, and we'll have links to all this in the show notes, of course, right? So Linkerd and Conduit and Buoyance as I think the parent company of all of that is one I've also seen deployed. HashiCorp's console also. And the funny thing to me is that they all use this Envoy proxy, which is yet its own open source project, right?
That's right.
But it's the programmability, right? It's the policy as code driver that you can implement with that. And then it's just different control planes on top. The thing that, to your point, Istio is really an amazing system because it takes that idea of control plane and really expands it out across all of the different platform concepts, all of the capabilities that we talk about, the observability, the traceability, the sort of the traffic management and policy injection. All of those components are I think really well formed in the Istio community. And then on top of Kubernetes, it's there. And then again, thinking about this in terms of leveraging something like a Google Anthos so that you can tie your data center into this as well without necessarily having to add in new VPN services. It really starts to become very interesting as a way of further expanding the system models.
Great.
I mean, again, as always, there's a lot more that we could dive into. We could go a whole lot deeper, but I think we've sort of run out of time for today. So you can always find us on your favorite podcasting channel, of course, and you can also check out our website at kumul.us, kumul.us. You can find us on LinkedIn at Cumulus Tech, and then, of course, Twitter and Mastodon. And you pick your favorite social media platform. You could probably find us there, and we'll have links to all of that down below. Right. So until next time, this is Robert Starmer.
And I'm Lew Tucker.
And thanks so much for watching Cumulus on Cloud.
Take care, guys.